today we're going to talk about how we went from a chaotic dashboard soup to a layered observability lasagna. And I'm sure that doesn't make any sense to anyone right now, and I'm probably going to make you really hungry before your lunch, but we'll dig into exactly what that means today. But first, I'm Martha, and I'm a product engineer at a company called Incident.io. And we build a product that handles end-to-end incident management, so an alert firing, paging you, all the way through to writing a postmortem. And I work across the stack, but I focus a lot about the reliability of our platform and the observability that enables that. So today, you're going to leave with a process to unsoup your dashboards, and I promise that's a very technical term. The importance of a layered stack to debugging. And then we'll end with some kind of practical tips for getting this to work really smoothly. But first, we're going to start with a story. So our story starts in early 2024. And we just finished building an on-call product. So something that handles your alerts, pages you, wakes you up in the night when something goes wrong. And I'm going to use on-call as an example throughout this talk because I'm sure, unfortunately, most of the room knows what it is to be paged. Therefore, you'll also know how important it is that you can trust your pager and know it will actually wake you up when things go wrong. So reliability is essential. And that's where we begin. In January 2024, we had a bare bones product, and we were due to release it in just 2 months. Reliability expectations were really high. We couldn't just release it and see what happens. And we had just 2 months to build that confidence. So where did it come from? For me, reliability boils down to 2 things. Proactive, so I need to know that my system will handle all of the things I expect to throw at it. But also reactive. Incidents are going to happen. We can't avoid that. We need to know about them really quickly and fix them even faster. And building confidence in these 2 sides is what meant that we could sleep at night in the early days of releasing this new, unproven product to the market. And what I learned is the core thing underpinning both of these is great observability. But what does great mean, and how is it any different from good? Luckily, taking your observability up a level doesn't mean reinventing the wheel. I'm not going to tell you to buy any crazy tools or rewrite everything. This is going to be much more of an approach and a strategy to how you think about building observability that makes a difference. But a very common problem is soup. And what do I mean by dashboard soup? Well, you probably have loads of single-use dashboards. Whenever you're in an incident, you're creating a new one and then losing it to the soup. And you're swimming around in all these visualizations. There's definitely some useful ones in there, but you can never find them when you need them. It can feel like you're doing all the right things with the right tooling, but it's just not sticking. And back in the start of 2024, that was me. I was in the soup. I was working in a system where I didn't feel confident using or extending our observability tooling. And previous companies I'd worked in hadn't got this right either. And I thought observability always tended to be this big mess that you just had to work out in emergencies. But in this talk, we're going to talk about how I got here. So we have a really reliable product, and it's been that way since we launched. We've got a really lovely observability stack that feels great to use. I've become an evangelist about it en route. But the most important thing is that our team all love it and contribute to it too. So it's not just a few keen engineers in the corner. Cool, so maybe I've got you all really excited about observability, and you all want to go build some dashboards, but that's exactly what we shouldn't be doing. Just building dashboards, metrics, and logs straight away is exactly how soup happens in the first place. So this is the key to unsouping your stack. Basically, we build observability in a kind of TDD-like approach, or test-driven development. And I'm sure everyone in the room has various opinions on whether that's always useful when writing code. But when it comes to observability, and it's an approach that lets you know that you're measuring the right things that are actually useful. We start with predicting. So we state something about our system that we think should be true. Then we prove it. We apply real load and see what actually happens. And finally, we measure. From those above steps, we've probably realized that we can't actually understand what's going on in our system, so we build the observability that tells us. And we continuously cycle through these until we have confidence that our system works exactly how we'd expect, but also, crucially, that our observability would tell us if it was going wrong. So predict. This is where we're going to state assumptions about how our system should behave under various conditions and establish what good looks like. But to make predictions, we need a really clear picture of our system. If you're working with something more established, you probably have this already, but if you don't, it's time to get your whiteboard out. So let's have a look at our on-call system. Essentially, we ingest alerts from third parties, like Datadog or Sentry, and we put notifications out, make people's phone ring. So alerts in, notifications out. Internally, it looks a little more complicated. And this is our real system diagram that we used when working on this. You want to make sure you split your diagram into boxes where each bit has a single clear job that can succeed or fail independent of everything else. And going back to predicting, we need to take each constituent part of our product and think of all the ways that it might experience strain. So first, we're going to zoom in on alert ingestion. So we want to write down predictions or questions about this. These shouldn't be testable with unit or integration tests. They should be real experiences of strain in the wild. So one example is alert storms. Let's imagine for a second that GCP goes down. Many of our customers are going to be experiencing massive alert storms and having a really bad day. And we need to know that we can continue to page them throughout that. So we're going to write down a load of these predictions, all sorts of ways that our system might experience weird things when it's running in production. And once we have those, we can move on to proving them. So proving that when we actually exert these predictions on our production system, it behaves exactly as we'd expect. Would anyone in the room feel comfortable deploying critical infrastructure without testing it first? Hopefully not. And you should really think of your observability tooling in the same way. You don't want to find out that your dashboards are broken when you first use them during an incident, so find out when you build them. The way that we got there was through a process we called drills. And that meant sitting in a room with a load of engineers, throwing all of our predictions at our system, and seeing how it behaved. So taking our prediction from earlier, we need to know that we can handle multiple customers having large quantities of alerts pouring into our system. But the really interesting word here is handle. What does that mean? For us, that meant we're doing the right thing in the time frame that our users expect. The rest of our app is unaffected, so we're not borrowing resources from other places. And if we not wanted to, we could probably handle comfortably more load. And now it's time to actually apply that load. And you can do this however you'd like, but we used Grafana's K6 to simulate a load of load tests. And what we found was we were missing the answers to a load of questions, and we weren't sure whether we were handling this at all. We had no visibility over what was slow, what it looked like to our users, and what parts of the system had particular bottlenecks. Cool, so we've made predictions, we've applied our load, and now we've got a load of questions that we're missing the answer to, which means it's time to measure. So we finally get to build some dashboards, and we want to now build the observability that answers all of our questions before. In this section, we're going to talk a whole load about dashboards, but they can be quite controversial because it's so easy for them to suck. So first, how do we avoid the soup? There are two classic mistakes when it comes to dashboards. The first is they often answer a really specific question. They're often a point-in-time picture of something that you thought would be interesting once. Naturally, you can only plot known unknowns, and Charity Majors has written a load about this. We want to make sure that if we're using dashboards, we're asking questions that continue to matter. So we use this as a triaging tool to let us know how the system is feeling to customers. The second issue is that they're often static and disconnected from the rest of your debugging stack. So when I receive an alert saying database CPU is high, that sounds pretty scary. I jump to a panel, but I can't really see what's going on or where I go next. It's really easy to create dashboards that leave an engineer stranded and with no idea how to find specific logs or more information. The core principle that we use to avoid these mistakes is treating our dashboards as a product. The way we make these dashboards good is constantly putting ourselves in the shoes of an engineer using them. So think about UX throughout. Incidents are really stressful, and you want your tooling to let you work really quickly with high confidence, not get in your way. The way that we do this is with a consistent framework applied across our stack, which is our lasagna. So a great observability stack should walk you all the way from a bird's eye view down to really specific requests. So we start with a really high-level dashboard, move through a more specific system dashboard, through logs, and then traces, which is the most granular detail we have on specific requests. Having a consistent framework means engineers don't have to see every dashboard to feel comfortable using it, and you want people to be able to jump into really unfamiliar territory during an incident and feel at home. And the engineer's journey through these layers is really important. So when we think about the most important piece of our lasagna, it's actually the arrows. And these layers are ineffective and won't be adopted if it's not incredibly easy to navigate from the top to the bottom. And that's why we always need to think about connecting our layers. So every time you build a piece of observability, a dashboard, or a visualization, you have to ask yourself where you would want to go next if you were debugging, and give an engineer a really nice big button to click on. So let's dive into our lasagna in action. We start with an overview dashboard, and this is the most high-level view of our system. We have one for each major part of our product offering, such as on-call. It's every engineer's first stop when they realize something is wrong, and it's ultimately a triaging tool. So this shouldn't give you all the details, but it should let you glance, assess the impact, and signpost you where to go next. You should put this dashboard everywhere. So we have it as our Grafana homepage. We bookmark it in Slack channels. Your team should see it as the first place to go, whether they're in an incident or not. So our overview dashboard contains a load of rows. Each one is aimed at quickly telling us if there's a problem with an area of the system. We start with infrastructure health. What is the state of the core pieces that our system relies on? Zooming in, we run on Kubernetes with a Cloud SQL Postgres. So that means we track CPU and memory for the relevant pods, and database health, including CPU and pool saturation. Next is queue health, rate limits, and then for each of those boxes on our system diagram earlier, we have a row, which gives us a really clear picture on whether it's happy or sad at a high level. Our alert routes, and then escalations. So are we paging people?
I hope you're enjoying this video, but did you know Lead Dev has a lot more to offer?
When I think about Lead Dev, I think about bricks and hearts. Bricks are those foundational things that you need to know, and Lead Dev provides that through webinars, through videos, through cutting-edge research. But hearts are the things that you need to glue yourself to the people at work. And Lead Dev does that through conferences and meetups.
Make sure you check out leaddev.com.
Diving into that, our escalation system runs on a Postgres queue, which means we need to know that we're processing it at a healthy rate. It's really important that each of these rows looks red and scary if something is wrong, even if it's minor. It's okay to have false alarms here. We're running a load test, so I can see that this is looking a little bit dodgy, which is a really good signal that I'd want to dive deeper. Going back to connecting our layers, I can click on that little escalations word right there, and it will take me to a more in-depth system dashboard to dive deeper. So that's our overview dashboard. It's a really simple traffic light of which areas of the product are healthy, encouraging you to triage and dig deeper where you see issues. Once we've identified the area the problem is in, we can dive into our system dashboard. So you come here when you know there's an issue with a system, but you don't yet know the impact or what's going on. It should give you an exhaustive picture of how well your system is doing its single job. So here is where you'd plot your SLIs or service level indicators. This should describe the scale of the customer impact, who it affects, and how much. And going back to connecting layers, this should link us straight to logs. A dashboard is absolutely not useful if you can't give people granular examples of things going wrong. That means the final part of each system dashboard is always log-based queries. We also have a filter that allows condensing to a single customer, meaning you can really quickly find targeted logs that you care about. Cool, so we've used our system dashboard to understand the issue, the scale of it, and who it's affecting. So we want to dig into logs to find a deeper example of that. And I'm not going to talk a load about logs and traces because that's a whole separate talk. But when we're thinking about UX, the really important thing here is consistency. I've been in a situation where I've had 5 different bookmarks for different log queries, and I can never work out how to find the ones I want. So having a pattern in your code base that means it's almost impossible to write well-formatted, useful context logs is really useful. Once we've found an interesting log, it's really important that we have a trace field to link us directly to our trace. And traces give us the most zoomed-in view to enable up-close debugging. You're probably not going to trace all requests for cost reasons, so it's really important that when you do have them, they're really useful and have context on all the pieces of slow stuff that you care about. So that's our lasagna, and this framework is what makes our observability UX great. The layers give this really consistent and understandable experience to anybody debugging. And this is a journey I perform all the time. So last week, I got paged for high CPU on our on-call worker. I head to the overview dashboard and diagnose it as a problem with our alert routing. From there, I see that it's an issue that a specific customer is having, and I find a log with a particularly high duration. And then I dive into a trace and find out that it's a database locking issue. So I've gone from a really vague alert to a really specific example with my hand being held throughout the debugging journey throughout. There's a load of technical details that make this work smoothly, so we're going to end by finish by going through some practical tips for how we make all these dashboards feel good. Firstly, we always want to think about user impact as our lens. If you've ever been paged for database CPU hitting 70%, you'll know that's scary, but it kind of means nothing on its own. It's a warning sign, but nothing could currently be on fire, and what actually matters is what the users of your system are seeing. Classic metrics like CPU, memory are really useful, but what will make your observability amazing is adding in the business logic that can only come from your knowledge of the system. So everyone in this room, it's your job to know the questions that actually matter about your own system and answer them. We layer that in with outcome fields. So earlier we said each of our systems has a single key job, and on that job we track an outcome field. Basically, you should be more granular than success or failure because you know that information and track that on your metrics. Another way we do that is user-observed times. Plotting latency is useful, but it's really important to think wider than how long did this function take to run to how delayed does this look to my end user. In modern software, things are going through multiple async processes before they finally finish. And so for us, we track execution delay. What was the time between an alert firing and a user actually being paged? This graph was on our escalations dashboard during our load test, and while some things looked a little scary, this peaked at 2 seconds, which is really comforting. This is always the first panel that I look at when I know something's wrong, because it really quickly gives you an idea of the scale of the impact. We also want to make sure we're always connecting metrics to logs. We said connecting those lasagna layers was really important, and the best way to do that is making sure behind the scenes you never have stranded metrics that don't let you pull that thread further. We do that through event logs. Basically, every metric tracked on individual requests should always have a corresponding log that you can search on. These are often called high cardinality events. Basically, you want a single, clearly formatted log that tracks your metric values and anchors the request. The important thing with event logs is that you always need to log them, even if your code is erroring. So have a pattern in your code base that means you know that this will still be logged if your code panics. You don't want to end up in an incident searching for the really important log and find out that it didn't happen. Finally, visualizing limits. Charts are so much more useful when they give you the context of how bad things actually are relative to your system's capacity. It means you know how long you have before things actually break and how quickly you're processing everything. This isn't always possible, but when you can, plot it on your graph. Plotting capacity is one way we do this. So this is a chart of work. We've got 6 escalations workers, which means at any one time, we can be processing 6 seconds of work, and that is our limit. We physically can't do any more. What's really interesting here is you'll see that line at 6 seconds wobbles because it's not a static limit, and it's a metric. So plotting capacity as a metric means you can identify really weird things, like just after a deploy, that's the reason that you stopped processing as much rather than guessing. This basically lets you know how behind you are and how much wiggle room you have before things get worse. So these are our tips, and these should make it super easy to build useful kind of dashboards, and it's important that all of your engineers have patterns for this and understand how to use them. The final thing we want to remember is not doing this on our own. So anyone can build a beautiful set of dashboards and logs alone, but there are many more people contributing to your code base and fixing your incidents, so you can't let yourself be the only person who feels comfortable with this stuff. Reliability isn't just your code, it's whether whoever is on call can get paged and quickly identify whether it's a single short-lived customer issue or a massive production issue that they need to get more people for. Doing this entire process, so running drills, building the dashboard, and exercising your system with your team is what gets them really bought in. You've built this amazing observability system, and you want them to own it and use it and contribute to it. Final tip we have here is game days. So think of our drills earlier as a test with the textbook open. There was no wrong answers. Game days represent throwing you right in the deep end and expecting you to use the observability tooling you have available to you. We run game days quarterly, and they're mostly kind of exercise to test our incident response and communication, but they're a really great way to see whether your dashboards are actually useful and how people are using them out in the wild. Cool. So good observability doesn't come for free with tools, and that is your job to understand your system and what you actually know is interesting. Doing that from theory alone is incredibly hard to get right, so using the predict, prove, measure flow means you'll be certain that your observability is actually going to tell you when something is wrong. And do it with other people. So Doing this with somebody else on your team means you share knowledge and get everyone more confident in using and contributing to these tools. Finally, if these problems sound interesting to you, as Lawrence said yesterday, we are hiring, so come and chat to me if you love observability. That's it. Thank you for listening, everyone.